We are now in subsets. Definition of a subset of a set. Set A is a subset of set B expressed as A subset B if every element in set A is also an element in set B. So here's the symbol again. It's like a C symbol, and then there is like a line at the bottom. So if I will say something like this as a simple example, and what we're going to put here, it's the subset symbol. So I'll use a different color here. So the answer would be this one. So since 1, it's the element of the other set, then that would be the symbol that you can use. For example, I have to use the other symbol. It is the notation A that is not a subset of B, means A is not a subset of B. Set A is not a subset of set B if there is at least one element of set A that is not an element of set B. So, for example, if I have like 1, 4 here, and then I have still on the other side 1 and 2. So, looking back to the definition, 4 actually is not an element of the other set over here. So it means our answer here is not a subset. So the symbol would be like this with a forward slash sign. And that's what it means. The last one, it's every set is a subset of itself. So for example, once you have like an empty set, and then you have an empty set over here, so that's a subset of the other set. Or if you have like 1 is an element of this set, and then the other one still 1. So that means that is still a subset of the other set because that's exactly the same. Then we can include also probably a different symbol for an empty set, like this circle with a forward slash sign, and then another symbol for empty set. It's using the braces. It's like 2 curly brackets. And our answer is just saying that should be a subset. Now, note that when you're looking at subsets, the formula to find the number of subset of a set would be 2 power of n, where n here it's the number of elements. N is the number of elements. Again, the formula is 2 power of n to find the number of subsets of a set. We can actually have an example for that one. let's say we'll try to pick 1 and 2 here, and it says how many number of subsets you have here. So since we have two elements here, 1 and 2, so we can apply the formula 2 power of 2, and we will get 2 power of 2, that's 2 times 2, we'll get 4. So that's the number of subsets within this set. So there are 4 number of subsets with that. So that's how you apply the formula. Okay, and what would be the subsets? So let's erase this part here. Let me write that again. Our example, it's 1 comma 2, and we said we have 4. That would be, the first one is the empty set. The second one would be the 1. And the third one would be the 2. So the last one would be exactly by itself. So that should be 1 comma 2. So let me label this. This is our first subset, second, and then third and fourth. So again, using the formula 2 power of n, which is 2 for this. You have 2 elements. So total of 4 subsets. Next would be the other symbol, and we call this proper subset. So here's the definition. Set A is a proper subset of set B expressed as A proper subset of B. So the symbol is without the line at the bottom, and that is the symbol for proper subset without the line. So if set A is a subset of set B and set A and B are not equal, so again, there is a condition. It says A should not be equal to B. So example, if you have like 1, 2, 3 in a set, and then you're asked what are you going to put here as a symbol. 1, 2, 3, 4. So let's apply the definition of a proper subset. So we assume that on the left it's set A, and on the right side it's set B. So it says set A is a proper subset of set B, expressed as A with that symbol like a C. That's the proper subset without the line at the bottom. If set A is a subset of set B and sets A and B are not equal. So are the two sets equal? No, they are not. So you can apply that symbol here. So we're going to use that symbol. And then now you might think about the symbol subsets. So we have the proper subset, and the symbol is this. And a while ago, we have just the subset, and the symbol would mean like a C, and then there's a line at the bottom. So looking at our example here, if you're going to choose between the two, then your answer would be both of the symbols can be applied here. So you can also use the subset symbol here. So both of them can be applied in this case. So what if I'm going to change um, and add something? So let me see if I have to change and add something here, like a 4 on the left side. So they are exactly the same now. So what would be the symbol that I'm going to use here? So the symbol I can only use, it's only the subset. The proper subset, it's a wrong answer now. So this one cannot be applied. Why is it cannot be applied? Because of the condition set here. So if you're going to remember, there is a condition set here. It says A should not be equal to B. Right now, A is equal to B. A is our left set and the right set is our B. So that's the difference between the subset and the proper subset. And I wrote a formula a while ago with the number of subsets you're looking for. The formula was 2 power of n. Now for proper subset, the formula would be 2 power of n minus 1. Okay, because the exact elements with the other sets, it's not included when you write out the subsets. So that's why minus 1. So it means that the subset has more number than the proper subset. So it's just one difference. Okay, so that's the difference between the subset and the proper subset. We can take another example. Let's say I have here letters for the set inside the set on the left, and then what would be your symbol here to use when you have another set on the right. You see, we will add one more. That would be S. So the answer would be you can use both of them. Okay, so let me mark that one. You can use the two symbol, both of them. So the answer would be the proper subset, and you can also use the subset. So either of the two. So you can use the two of them. Okay, another example. Let's say I'll have here 0, 2, 4, 6, 8. And then on the other side, I have here 8, 0, 6, 2, and 4. Now, if I'm going to trace the given problem, so 0, so we have 0 here, and then 2, we have 2 on the other set. 4, I have 4 on the other set. 6, I have 6 also over here. And then 8, that's the first one we have here. So it's just not arranged in order, but that's exactly the same set. So what do you think would be the answer? The answer would be just the subset, like this, with the line at the bottom. Now, I'm trying to emphasize this symbol so you can remember this for a long time. So subset has this like a C and then a line here. The line here actually means if you're going to think about something, just think about the line here means equal sign for the line. Remember before we're using like less than or equal to, greater than or equal to. So there's a line at the bottom. So I think that's easier for you to memorize. So looking at this two sets, I'm going to mark this out. Um, this first set here, that's set A, and then the other set on the other side is just equal to each other. So that's why you're using that symbol, just the subset, not the proper subset. So you cannot use that. Unlike on the first example, you can use both of them, the proper subset and the subset. Okay, so using the formula, we can actually write the different subsets. So let's have another example like 1, comma 2, 3, and then we're asked to list all distinct subsets out of this set. So the first one is the empty set, right? So we have the empty set first, and then we can have the 1 as an element, and then we have 2 as an element of that set, and then we can have 3 as an element, and then we can have um, 1 and 2, right, as an element, and then we can have, let's say, 2 and 3 as an element, and then I can actually write 1 and 3. So counting that 1, 2, 3, 4, 5, 6, 7, and then the last one would be itself. So that would be 1, comma 2, comma 3. So let me label that. So this is the first one, second, third, you have the fourth one, fifth, sixth, seventh, and eighth. So remember the formula for finding the number of subsets would be 2 power of n. And n here is the number of elements. So you count 1, 2, 3. So you have 2 power of 3. And that would be 2 times 2 times 2. So you will get 8 subsets. And that's how you find that. If you're looking at the proper subsets, that would be 2 power of n minus 1. So you have only 7 proper subsets. So what's actually going to be not in there? It's the last one because you cannot equal it to itself, right? So this one, we remove that. So you have only 7 instead of 8. So that's the difference between proper subsets and the subsets. Okay, just don't forget the symbols and memorize the definition. So I think it helps you if you remember that line at the bottom means an equal sign. So you can actually remember this for a long time.